Algebra 2, 4-7, transformations of quadratic graphs. All right, so we're going to start with our the form that we've been using for quadratics has been ax squared plus bx plus c. That's the form that we've been using, but we're going to learn a different form called vertex form. And vertex form looks like this. Y equals, or f of x equals, a times x minus h squared plus k, where h and k is the vertex. Now, this h here, see how we have minus h here? And then this would be a positive h. So just know that this is going to be the opposite of what you think it should be based on what's in here. So if it's minus h in here, then this is going to be positive. If this is plus h in here, then this is going to be negative. So there's a little bit of a translation you might need to do just to help you see that that x value of the vertex is the opposite of what you think it might be based on what's in there. Okay, now we're going to write a bunch of stuff down here with arrows up to this equation. So this a here, it changes the shape of the parabola, of the quadratic, and it gets squished like this, squished. So if the absolute value of a is greater than 1, meaning it's not a fraction between 0 and 1, then it makes the parabola skinnier. So it squeezes it in like that. If the parabola is, oh gosh, I should write this a little bit better here. If I have 0 is less than the absolute value of a is less than 1, meaning it is a fraction between 0 and 1, or 0 and negative 1, because we have an absolute value here, then it's going to make our parabola flatter. So it's going to make it like this. It's going to squish it that way. So this one I didn't even write skinnier, I just said skinnier, didn't I? So if it's greater than 1, if the absolute value of a is greater than 1, then it's going to squish it in like this and make it skinnier. If it's a fraction between 0 and 1, or 0 and negative 1, then it's going to make it flatter like that. This also decides the direction of the opening. So if it's negative, then it's going to open down like this. If it's positive, then it's going to open up like this. All right, let's see if we can fit the rest of this stuff in here. Oh, there's not a whole lot left, actually. We're going to look at this h here. If this is positive, or if this, probably shouldn't, let's see here. This arrow should probably be pointing at that negative there. So if it's positive, then you're going to move the parabola to the left that many spaces. And if it's negative, then you're going to move it to the right h many spaces. So again, opposite of what you think it might do. All right, that's all we're doing with this little schematic here. Let's go on and let's talk about, we're going to write an equation, and we are going to change this to vertex form. So this is our standard form that we've been using, and we are going to change this to vertex form. And the way we do this is we need to, oh no, really? Yes, we do. We need to complete the square. So if you remember, we say what's half of this, which is 3, and then you square that, and that's what you add to both sides. So I'm just going to ignore this 5 for right now. I could put it over here with the y, but I want y to be by itself eventually anyways. So I'm just going to move the 5 over. So I've got y, so 3 squared is 9, so I'm going to add 9 to both sides. So y plus 9 equals x squared plus 6x plus 9 plus 5. I'm not going to add those two together yet because I want to do this complete the square thing. Now if you wanted to figure out, oh, 9 is, 4 added to 5. You could just add 4 to both sides, and 4 plus 5 is 9. Okay, you can complete the square that way. I think that's more brain work than you really need to do. So I do it this way. I add 9 to both sides. I just leave that 5 out. I'll worry about that 5 in a little bit. Okay, so 3, it was half of 6, so I know that this right here is going to be x plus 3 squared, and then I say plus 5, and this is still y plus 9 on this side. Now I'm just going to subtract 9 from each side, and I've got y equals x plus 3 squared minus 4. And now I have completed the square. I have written this in vertex form, and I can now say, what is my vertex? My vertex is, here's my x value. Remember, I do the opposite of what it looks like in here. -3, -4. So there's my vertex. My axis of symmetry is x equals -3. The axis of symmetry, remember, is the x value of the vertex as an equation here, x equals -3. So that would give me my line that is the axis of symmetry for this parabola here. Let's do another one. Y equals -2x squared plus 8x minus 3. Okay, so now I've got a difficult scenario, but we can handle it. I'm going to take this -2 out. Y equals, well, not out, but I'm going to factor -2. From this section here, I'm going to ignore the -3. Just ignore it. X squared. I pulled out a -2. That means that this 8, I'm pulling out a -2 from the 8, so I got -4x minus 3. Now here's the part that's the most difficult, and something I don't believe we've talked about yet in this class. And that is that I need to, this half of -4 is -2. -2 squared is +4. So I need to add 4 in here, but what I'm really adding to this side is not +4. Let's write it and see if we can figure out what I'm talking about here. -2 x squared minus 4x plus 4 minus 3. So I added this 4 to this side. But really what I've added is 4 times negative 2 on this side. Because if I were to factor this negative 2 out of what's in the parentheses here, there would be a negative 8 in this spot. But I pulled the negative 2 out, so that means, so that's why I have a positive 4 here. So positive 4 times negative 2 is negative 8. So I've added to this side a negative 8. So that means I also have to add a negative 8 to this side, or subtract 8, however you want to say it. That's the trickiest thing with completing the square that there is. Okay, now we just move on here, all right? So y equals, I'm going to add 8 to both sides so I can get the y by itself. And then I've got negative 2 times x minus 2 squared, right? That's what this is, x minus 2 squared. And then negative 3 and positive 8 is going to give me a positive 5. So I have completed the square. There it is. My vertex is positive 2, positive 5, 2, 5. My axis of symmetry is my x value, which is positive 2, x equals 2. Now I have another question. Which way does this parabola open? Does it open up or does it open down? So look back at your notes up here. If the a value is negative, then it's going to open down. Down like this. It's going to be down like that. All right, let's see if you can do one on your own. Oh, I've got several you tries. Oh, goodness. All right. I think we're just going to do a bunch of examples here. All right. You try. Y equals x squared plus 4x plus 6. I want to know the vertex. I want to know the axis of symmetry. And I want you to write this in the vertex form, like we've been doing. So I'm going to give you all 3 of these examples. Y equals 2x squared minus 12, minus 12x plus 17, and y equals negative 3x squared minus 18x plus 10. All right, so all of these I would like them to be in vertex form, and I want to know the vertex and I think and the axis of symmetry for each one. And you should know whether it opens up or down. All right, so go ahead and pause and get to work on those, and we'll come back and we'll work through them all pretty quick, hopefully. All right, go. All right, let's see how you did. So I need to change this to vertex form, and I'm going to ignore that 6 for right now. I'm just going to put it off to the side, and I'm going to find what is half of 4 is 2. 2 squared is 4, so I'm going to add 4 to both sides. Plus 4 plus 4. I get y plus 4 equals x squared plus 4x plus 4 plus 6. Remember, don't forget that 6. Even though we're trying to ignore it, we need to keep that here. All right. I'm going to do 2 things at one time here. I'm going to subtract 4 from each side, and I'm going to change this to be x plus 2 squared. Y equals x plus 2 squared. That's this perfect square. And then 6 minus 4 is 2. And there I have written this in vertex form. My vertex is negative 2, positive 2, negative 2, positive 2. My axis of symmetry is x equals negative 2. And this is going to open up. like this. All right, the next you try, I'm going to first take these guys and say y equals 2, I'm going to factor this 2 out, 2x squared minus 6x plus 17. And then half of negative 6 is negative 3, squared is 9. So I'm going to add 9 to both sides, except for I'm not really adding 9 to both sides. I'm adding 9 inside this parentheses here. But I have to multiply it by 2, so I'm really adding 18 to both sides. So I'm going to add 18 to this side. I'm going to add 9 to this side. So let's just rewrite it just for the sake of cleanliness. X squared minus 6x plus 9 plus 17. So I've added 18 to this side and I've added 18 to this side. Now I'm going to do that same thing I did before where I do kind of two things at one time because we're in Algebra 2. We should be able to handle that. Y equals, so subtracting that 18, 2 times x minus 3 squared, that's what this mess is. And then positive 17, negative 18 is negative 1. So my vertex, vertex equals positive 3, negative 1. You don't have to write that positive there, but I just did just because. All right, axis of symmetry is x equals 3. And it opens up again. Last you try, let's see how you did. I'm going to take this by itself. I'm going to try to ignore that 10. I'm going to factor out a negative 3 from negative 3x squared and negative 18. Y equals negative 3 times x squared plus 6x plus 10. So the way to check my work to see if I factored this right, I would distribute this back in again, and I should end up with what I had originally. So I would have, if I multiply this negative 3, that looks good. If I would multiply this negative 3 times the 6x, then I would get this negative 18x, so I've factored correctly. Now, I need to decide what is half of 6. It's 3. What's 3 squared? It's 9 again. All right, so I'm going to add 9 in here. And what I'm really adding to this side of the equation is 9 times negative 3. So that's negative 27. So I'm really adding negative 27 to this side. I also need to add negative 27 or subtract 27 from the other side. I need to do what I do to one side, I do to the other. So let's rewrite this whole thing. Y minus 27 equals negative 3 times x squared plus 6x plus 9 plus 10. All right, let's add 27 to both sides. And let's change this to say y equals negative 3x plus 3 squared. 10 and 27, adding those together is 37. All right, vertex. Vertex is negative 3 and positive 37. And my axis of symmetry is x equals negative 3, and this opens, my a value is negative, so it opens down. And so the parabola is going to look something like that. All right, we got a little bit more to go here before we're done with this lesson. One more kind of example here. And this example that we're doing is write an equation given a graph. So let's do an example. We're just going to do two examples, an example and a you try. Okay, let's draw the graph. And the graph looks something like this. It's not super good. Let me give it a little bit more. There we go. All right, so the vertex here, we're just going to say this is the vertex. Didn't do an awesome job drawing this, but there you go. The vertex is 3, 2. And then we have this random point down here that is -1, -2. Okay, it's not to scale, just pay attention to what the points say. So we are going to start with our vertex form, y equals a times x minus h squared plus k. So this is our vertex. 3, 2 is our vertex. So we can just plug that right in. Y equals a times x minus 3. Remember, this is positive, so we're going to keep this saying minus 3 squared, plus 2. This is my y value, this is my x value, this is my y value. All right, we're almost done. Now we just need to find out what this a is. And the way we do that is, remember when we used to use slope-intercept form and we would plug in points to find the b value? We would plug in the point, and if we had the slope, then we could find the b value, or if we had the b value, we want to find whatever. All right, here we go. We're doing the same kind of a thing here. What we're going to do is, I'm going to say this is my x value, this is my y value, and I just plug those in, and I should be able to find a. So y is -2, x is -1, and I just solve for a. So I am going to say -1 plus -3, or -1 minus 3 is -4. -4 squared is positive 16. -2 equals positive 16a plus 2. Subtract 2 from both sides. -4 equals 16a, divide by 16, divide by 16. A equals -1/4. So that's not my answer. I'm supposed to write the equation given the graph. So I'm going to write the equation over here because that's where I have space. Y equals -1/4 times x minus 3 squared plus 2. So I use my x and my y from my vertex. Here they are. And I found my a value. There it is. Notice how this graph is kind of flat. That's because I have a fraction that is between 0 and 1, or between 0 and -1. And so it got squished. That way it got flattened rather than this way. All right, let's see if you guys can do one following what I just did here. So now I've got a point here. I'll do a little bit better job here. -1, 1, 2. So here's the point, -1, -2. And then I have another point that is 1, 2, 3, 4, -4. And way up here is going to be 13. -4, 13 is my random point. Here. Okay, there's my vertex. There's my point on the parabola. I'm going to write for you vertex form, just to help you remember. Plug in the numbers, find what a is, and then rewrite the equation at the end. Don't be scared if you get a fraction. We'll talk about that in a minute if you do get a fraction. All right, pause and go. All right, let's see how you did. All right. Okay, here's the vertex. -1, -2. So y equals ax plus 1, remember it's the opposite of what you think it might be, squared, minus 2. Okay, now I'm going to plug in my x and my y values there. So I'm going to get -x for 4 and 13 for y. Let's just write those out. 13 equals a times negative 4 plus 1 squared minus 2. Negative 4 plus 1 is negative 3. Negative 3 squared is 9. 13 equals 9a minus 2. Now I'm going to add 2 to both sides. I've got 15 equals 9a. Oh, gross. All right, divide both sides by 9. I'm going to say that, so that becomes 1. And so 15 divided by 9, let's divide both the top and the bottom by 3, the greatest common factor of both of those. So we can simplify this fraction a bit. 5 over 3 equals a. Okay, 5 over 3 equals a. So let's rewrite the whole deal. Y equals 5 over 3 times x plus 1 squared minus 2. Now, if you got that, you got the right answer. But wait a second, Mr. V. You said if there's a fraction, this would be squashed this way, not squished in this way, right? It's not flattened the way that a fraction does. It's squished this way. Now, you might know the answer, and that is because 5/3 is really 1 2/3. 1 2/3 is a fraction greater than 1. So several times I've said, if it's a fraction between 0 and 1 or between 0 and negative 1, then it'll flatten the graph like this. If it is a number, fraction, whatever, that is greater than 1 or less than negative 1, then it's going to squish the graph in this way. And so that's what happened here. This is greater than 1, and so there we have it. And that is the end of section 4-7. Good luck on the homework.